Alright, so continuing with polygons and similarity. So at the end of yesterday's lesson, we talked about the ratio of perimeters is the same as the scale factor. So, alright, sorry, I had to pause the video there for a second. So you'll have some problems today that we'll start off by saying something like this. So if it says like the perimeter of smaller polygon is, let's say, 20. And then it will have the ratio of the perimeters, and let's say that the ratio was like 4 to 5. So hopefully those numbers work out. I just made them up. So smaller polygon is 20 and the ratio is 4 to 5. So remember, we can write the ratio as like a fraction. And since it said smaller is 20, then it has to go across from the smaller number in the ratio, and then it's just solve for x. So, we talked about yesterday, like, well, 4 times 5 is 20, so if I do 5, then x is 25. Okay, if this said, if I change this problem, the perimeter of the larger polygon is 20 with the same ratio, then I'd have to put the 20 across from the larger number, and then you could still say, well, times 4 and times 4, and so x is 16. Excuse me. Okay, so just the key, perimeter of the smaller polygon, perimeter of the larger polygon, put the actual perimeter across from the larger or the smaller number of the ratio. Okay, so the harder one is area. So, area of similar polygons. It's not like a ton harder, but so if it says here that triangle ABC similar to triangle DEF, and so on some of them, like, that's really sloppy, but it's not necessarily super important that you have the pictures. It just depends on what it's going to tell you. So DEF. So on this one, so it's saying the area of this first triangle, ABC, is 36. And it wants you to find the area of the other one, DEF. Excuse me. And so the relationship with area and similar is like, if you were to tell me like the area is something you're supposed to put, the area is feet squared or meters squared or whatever the measurement is. So if I put an M, it would be meters squared. So the scale factor, it's bigger to smaller. So I can reduce that. Okay, but and when I set up my proportion, you'd say, okay, well, if they were equal, I would have it like this. Or excuse me, I would have it the other way around. The bigger one is 36, so the bigger one. Okay, and that's what we would do if it was perimeter. But because it's squared, you have to square the scale factor. 1 times 1 is 1, 2 times 2 is 4. So instead of having a 2 here, you're going to have a 4 here. And you could, goodness gracious, excuse me, do that same, 4 times 9 is 36, so 1 times 9 is x. So the area of the smaller one would be 9 meters squared. Okay, so just before you set up your proportion, do the scale factor and square it. Then the area, if it's the smaller one, put it across from the small number. If it's the big one, put it across from the big number. So the only difference is area, you have to square the scale factor. Perimeter, you don't square it. All right, and then, so you have some questions on perimeter and then some questions on area. And then the last one, I'll go back to just finding like the scale factor. It's going to give you a picture, 2 polygons, and then, find the scale factor of this one to this one, find the scale factor of this one to this one, find the value of x. There's different, things to look at. Find the area of, the polygons, stuff like that. So those are just kind of extensions of what we've already been talking about. All right. So hopefully not too difficult. So just kind of a little bit of an extension from yesterday. Perimeter, scale factors, and ratios are the same. Area, the ratio is the scale factor squared. That's the big piece of information to remember. Okay. Hopefully fairly short and sweet with what you have to do. So hopefully you guys are doing good. Almost through the first week. Have a great rest of your day, and we'll see you tomorrow.